Yeah, so these are again the repetition. So problems in surveys is poor sampling, which also makes your instrument less reliable. So poor question design and wording, failure to operationalize, incorrect or biased responses could be there. There could be low responses or no responses at all. So these are certain problems that we ought to tackle during finalizing a questionnaire or a survey-based study. So, yeah. So structured questionnaire is the one wherein we have the MCQ based questions, and for example, I frame a question. Let's take any question for that matter. How satisfied are you with your job right now? Okay, and I ask you to answer this question on a scale of 1 to 5, where 1 stands for highly dissatisfied, 2 stands for dissatisfied, 3 stands for neither dissatisfied nor satisfied, 4 stands for satisfied, and 5 stands for highly satisfied. These kind of questions are known as structured. When all my questions in a questionnaire are of this structure, it is known as a structured question. Semi-structured, wherein we have mix of both open-ended questionnaires and structured questions. Unstructured questionnaires could be when I am soliciting a response. For example, I ask the same question: How satisfied are you with your job right now? And I leave the answer as in a descriptive answer. So that becomes an unstructured questionnaire. Obviously, the difficulty is in analyzing the unstructured questionnaire answers is greater as compared to analyzing this structured questionnaire. Yeah? We will not be able to perform any kind of inferential statistical tools on unstructured questionnaire, but now we have a lot of software from where we can analyze the pattern. For example, I interviewed 10 teachers and I figure out what are the factors or the driving forces of their satisfaction level in University of Delhi, for example. So I will be able to identify certain themes and certain patterns from their responses. So since the difficulties in cases of unstructured questionnaire or open-ended interviews is higher, we also need a lesser sample. Okay, but again, generalizability is a question mark here. So obviously, both the tools, all the 3 tools have their pros and cons. Yeah? So there can be different types of questions, So is it going to be an open-ended questionnaire or is it going to be a closed-ended question? For example, the first example of scale of 1 to 5, that was a closed. And the second example, wherein I wanted to solicit a descriptive answer, that is an open-ended question. Then we choose the metric. Is it going to be nominal? Is it going to be ordinal, interval, or ratio scale? Okay. So there are different types of questions. Again, other the categorization is that we have dichotomous question, which are usually yes or no. For example, it was a dichotomous question, wherein you can either answer a yes or no. Yeah. Yeah. Then we have multiple choice questions. Yeah. There can be one response of the 5 or 4 given options, or there can be many responses also. For example, again, how satisfied you are with a particular product, you rank it from 1 to 5. So you can either choose 1 or you can choose 2, you can choose 4 or 5. You cannot choose 4 and 5 simultaneously, in the one go. But similarly, if I ask you which of the following brands you use for toothpaste, now there can be more than one answer. So multiple choice, there could be one response multiple choice questions, there can be many response multiple choice questions also. And then rating scales, so odd number should be there or even number would be there. Do you want to assign a 0? For example, the 5-point Likert scale is an odd number. We have 0 as neither satisfied nor dissatisfied, and then we have 2 on the other side. Open-ended, obviously, when we want to have a free response, then we have open-ended questions. So yeah, this is just the explanation of what we just discussed. Example, what is your gender, male and female? This is a close-ended question. What is your ethnic identification? African, American, Indian, Asian Pacific, European. These are all close-ended questions. What is your age? So when we are specifying, we are grouping, we are providing with the categories, and we do not have any other option. Yeah, so that's a close-ended questions. How satisfied are you with social work? Very satisfied, satisfied. So these are all examples of close-ended questions. Yeah. Now, if I frame the same question, what is your would become a what? A ratio rate at 29 years, 32 years. Yeah. Now let's move on to the next subtopic, that is research questions. A research question. Now, what is a research question? A research question is a clear, concise, and it's a focused query that a researcher seeks to answer through investigation, through analysis. And it defines the scope and direction of the research study, guiding the collection and interpretation of the data. So, an ideally well-formulated research question, it is specific, it is relevant, it is measurable, and achievable within the constraint of the research project. Now, an example of research question could be, how does regular, say, exercise impact cardiovascular health in adults over the age of 50? That could be one research question. And research question, these are another 3 examples of research questions with context to the higher research in higher education. How, for example, how has the governance and management of Indian higher education evolved? How the governance and management of higher education functions at the national and state level. Another question could be, how are higher education institutions governed and managed? So all these are research questions. Now, next comes the research objectives. Now, what are research objectives? So research objectives are specific, measurable, and achievable goals that a researcher aims to accomplish through the research study. They outline the purpose and intent of the research, providing a roadmap for conducting the investigation and reaching, we can say, meaning conclusions. So research questions and research objectives are what guides the researcher towards the design, towards finalizing the research design, the methodology, and the analysis of the study. Yeah. Continuing with the cardiovascular example that I was giving. So research objective related to the activity would be, first research objective could be to, say, examine the relationship between. So we can have research objectives for these 3 research questions as to discuss the evolution of the governance structure and processes at the state and institutional level, to study the role and colleges level, to study the management of higher education at the institutional level. These could be certain research objectives with reference to the research questions that we frame. So research question is a broader arena as compared to research objectives. So research objectives, when a research question is broken down into measurable and achievable outputs, that becomes a research objective. So we have research instruments. Research tools can be there for quantitative data. For example, we can, for the same, I'm considering the same example, themes and the factors, we can have interview with them. There could be semi-structured interview schedule or guide. Then we can also have interview schedule for the student council members or the leaders, interview schedule for the state bodies, Directorate of College Education, State Council of Higher Education. We can have instruments. So mixed method approach would be what? Combination of both quantitative as well as qualitative methods. So we will be capturing good governance and management through different parameters, and we would want to see the best practices and assess what are the current governance structure and practices. Yeah. So for quantitative, we can have questionnaires. For example, this would be a snippet of what a faculty questionnaire might want to gauge: basic profile, family background, workload, job satisfaction, facilities for teaching research, policy effectiveness, and other factors such as transparency, autonomy, strategic vision. Yeah. We can also ask them to for the parameters related to the financial management, related to accountability, the communication within the organization, their awareness with respect to the UGC rules and guidelines that are applicable on them. Typical student questionnaire might have, again, the basic profile, the demographic factors, and then how do they rate the existing facilities for learning, the campus support services, the administration support, the student, the union, the campus environment, library services, student services, hostel, canteen facilities, sports facilities. We can ask them to rate about this. Yeah? And qualitative instruments with respect to the interviews with the vice chancellors, dean, registrars, and so on. And there could be focus group discussion with the students also. And this is what I was talking about, the Likert scale. This is a 4-point Likert scale example from the faculty questionnaire. Okay, and there are 4 options that you can choose: disagree strongly, disagree somewhat, agree strongly. And I've extracted it from one of the questionnaire. I am satisfied with the opportunities to collaborate with colleagues in my department. That's the example. Now let's move on to the parameter that I wanted to refer to, reliability and validity. Okay, so I'll be sharing another slide for that. Please confirm if it is visible.
Yes, sir. Yes, sir. Yes, sir.
Okay. We've already discussed. So in everyday life, we probably use reliability to describe how something is valid. So what I mean to say is, we as layman, as a lay person, we use these 2 terms, reliability and validity, as interchangeability. Yeah, interchangeably. So, but these are not the same things. And evidence-based practice includes, in part, implementation of the findings of well-conducted quality research. So, being able to critique quantitative research is an important skill for researchers. And consideration must be given not only to the results of the study, but also to the rigor of the research. And this rigor refers to the extent to which the researchers worked to enhance the quality of the studies. So in quantitative research, this is achieved through measurement of the validity and reliability. And when it comes to data analysis, so reliability refers to how easily replicable an outcome is. For example, if you measure a cup of rice 3 times and you get the same result each time, that implies what? That the result is reliable. Validity, on the other hand, refers to the measurement's accuracy. For example, if the standard weight for a cup of rice is 5 grams and you measure a cup of rice, so it should be 5 grams. If it is coming as 4 gram or 6 gram, then obviously the cup is not a valid instrument. So while reliability and validity are intertwined, they are not synonymous. And if one of the measurement parameters, such as your scale, is distorted, the results will be consistent but invalid. And I use the simple example of validity and reliability through an alarm clock. Under the alarm clock example. Suppose there's an alarm clock which rings at 7 each morning. पर उसको set हमने 6:30 के लिए किया हुआ. Now it is reliable. Why? Because it consistently rings the same time every day. It is reliable. But is it valid? No. Why? Because it is not ringing at the desired time. It is ringing at 6:30 when it has to ring at 7. So a clock that has been wrongly set at 6:30 is going to be reliable because it will have consistent outcome, but it will not be a valid. Yeah. Now let's see a video. I know audio will not be, this will not be audible to you, but just go with the visuals. It's a small video that will just humorous way to understand why reliability and validity is important. Yeah, so we could see in the video that the poor chap was left behind by his fellow and that he had a problem that he wanted to move from point B, but there was the gap. And that is perhaps we also do in our research, right? We try to bridge the gap. We try to find out the solution to the problems. We propose new approaches, or we try to prove previous theories, or if the theories are pragmatic or applicable under different situations. That is what we all do in our research. So that was the research problem here, bridging the gap to move from point A to point B. And that is why he had to do something with C, which was the research instrument analogy. Yeah. Now he found the means to cross the bridge. So he had the solution. He tried the solution, but the solution was not reliable one. It broke down. So he had to go back, do some more research to find a new solution and test if this was reliable or not. So we could see that before actually traveling through the instrument that he had built now to cross the bridge, he tested it with his one leg so as to know if it was reliable or not. So similarly, in our research, we ought to provide the solutions or approaches which are reliable and which can be used by future researchers. Okay. Now let's see another video, again a small video to understand another aspect of reliability. Again, audio will not be, the video will not be audible, but you just go for the visuals. Yeah. So there was one solution, that is the wool, but it had its purpose and solution across different time zones and different situations. So similarly, our research should also be reliable across such parameters, different time, different sample. Yeah. Now let us delve into what actually is reliability in the context of research instrument. Maybe adjust the slides. Yeah. So in the context of research instrument, so when a measurement is consistent, it's reliable. But of course, reliability doesn't mean your outcome will be the same. It just means it will be in the same range. For example, if you score 95% on a test the first time, the next time you score 96%, your results are reliable. So even if there is a minor difference, a difference in the results, in the outcome, so as long as it is within the error margin, your results are reliable. So reliability allows us to assess the degree of consistency in our research. So if you're getting similar results, reliability provides an answer to the question of how similar our results are. Similarly, if you talk about validity in a formal way, so validity, a measurement or test is considered to be valid when it correlates with the expected result. So validity examines the accuracy of our result. Okay, and here is where the things get a bit tricky. Now, to establish the validity of a test, the results must be consistent. Now, looking at most experiments and specifically the physical measurements, the standard value that establishes the accuracy of a measurement is the outcome of repeating the test to obtain a consistent result. For example, before I conclude that all 12-inch rulers are 1 foot, I must repeat the experiment several times and obtain very similar result, indicating that 12-inch rulers are indeed 1 foot. So most scientific experiments are inextricably linked in terms of validity and reliability. For example, if you're measuring distance or depth, so valid answers are likely to be reliable. But the problem arises in social sciences research, wherein one is not the indication of the other. For example, most people believe that people that wear glasses are smart. Yeah. Of course, we can find examples of people who wear glasses and who have high IQs. That is reliability. But the truth is that most people who wear glasses simply need their vision to be better. So reliable answers are not always correct, but valid answers are always reliable. Okay. Okay, since we have a paucity of time, I cannot go into depth of how reliability is assessed and how validity is assessed. But yeah, I will talk briefly about the different types of reliability tests that we have. So when assessing reliability, we want to know if the measurement can be replicated or not. Of course, we would have to change some variables to ensure that this test holds. And the most important of which are time, items, and obstacles. So psychologists consider these 3 types of consistencies. One is over time, which is known as test-retest reliability. That implies what? You perform the study today and you perform the study, say, after 1 month, after 2 months. Now, this quantum of time has to be decided on the basis of the context. Yeah. So if I am measuring hair growth, I cannot measure my hair size today and tomorrow. Obviously, it is going to be negligible. So that would not amount to consistency. There has to be substantial time period in between. So when we change the time period as a variable and perform the test again, that becomes test-retest reliability. And another important reliability is internal consistency, which is across items. Yeah. And there are again different tools, not tools, I would say different measures of internal consistency. One is Cronbach alpha. Another one is split half test reliability that measures internal consistency. So instead of considering responses of all the scales, we divide the questionnaire into 2 halves and measure the average and compare these averages. That is what is given by, and then we measure the correlation between the two averages, 2 scores that we get. Higher the correlation, higher would be the internal reliability. And similarly, the last one is inter-rater reliability, wherein we change the researchers. And this is akin to the situation wherein we, for example, all the beauty pageants or all these singing shows that we have, there's a panel of a few judges, 2 to 3 judges. Yeah. So that is inter-rater reliability. Again, there are different statistical measures for these. So we're not going to talk about this in detail. Now moving on to how validity is assessed. So again, there are different forms of research validity, and main ones which have been specified by a heavily cited researcher, that is Cohen et al. Paper 2007, are the content validity, criterion related validity, construct, internal, external, concurrent, and face validity. Okay, but the 3 most important ones are content validity, which measures the extent to which a research instrument accurately measures all aspects of the construct. Construct validity is the extent to which a research instrument or tool measures the intended construct. And criterion validity is the extent to which a research instrument is related to other instrument that measures the same variable. For example, if I am measuring, say, the stress level, and stress and anxiety are related construct, right? And when I try to find out the criterion validity, and I figure out that my instrument is indeed measuring the anxiety levels, then obviously there is criterion validity issues in my instrument. Another type is The first category, in fact, is content validity. And this category looks at whether the instrument adequately covers all the content that it should with respect to the variable. For example, suppose I want to test the hypothesis that 90% of Generation Z uses social media polls for survey, while 90% of millennials use forms. So I would need a sample size that accounts for how Gen Z and millennials gather information. So content validity refers to determining the validity by evaluating what is being measured. So it tests if your research is measuring everything that it should to produce an accurate result. Yeah. For example, if I were to measure what causes hair loss in women, now I will have to consider things like postpartum hair or hair manipulation, dryness, and so on. If I omit any of these critical factors, I will significantly risk reducing the validity of my research because I would not be covering everything necessary to make an accurate deduction. For example, there is a certain woman in my sample who is losing her hair due to postpartum hair loss or excessive manipulation and dryness. But in my research, I only looked at postpartum hair loss. So my research will show that she has postpartum hair loss, which might not be actually accurate. Okay, so yeah, my conclusion is correct, but it does not fully account for the reason why this woman is losing her hair. And the subset of content validity is face validity. A face validity mein what do? We go and we ask experts about their opinion as to whether an instrument measures the concept intended. Okay, it's how we anticipate a test to be. Now there are no quantitative measure for face validity. For example, when answering a customer service survey about the service provided. Okay, so face validity is the extent to which a measurement method appears on its face to measure the construct of interest. And so face validity does not have a quantitative measure, so it is at best a very weak kind of evidence that a measurement model is measuring what it is supposed to. Yeah, and one reason is that it is based on people's intuition about human behavior, which are frequently wrong. So it is also the case that many established measures in psychology work quite well despite they lack face validity. Another example is that less than 40% of men over the age of 20 in, say, Rajasthan are at least 5 feet 10 inches tall. The most logical approach would be to collect high data from men over the age of 20 in Rajasthan. Yeah? So, however, asking men over the age of 20 what their favorite meal to determine their height, that is something pretty bizarre. So, the method I'm using to assess the validity of my research is quite questionable because it lacks correlation to what I want to measure. Talking about criterion validity is when I compare my result to what I am supposing to get based on the chosen criteria. Yeah? It is the extent to which individuals score on a measure are correlated with other variables which are known as criteria that one would expect them to be correlated with. I will consider just one example and move on. For example, individual anxiety should be negatively correlated with the performance in an exam. Now, if it were to be found that individuals or the students' score were in fact negatively correlated with their exam performance, then this would be a piece of evidence that these scores really represent my students' test anxiety. Okay. But if it were found that students scored equally well on the exam, regardless of their, this would cast certain doubt on the validity of the measure. Now, coming back to the previous slides, so this is what validity and reliability is, and how we can, what are the different types of validity and reliability. How do we ensure? Again, there are various methods to do it. For example, for content validity, we can have expert review, we can have literature review, we can have pilot studies. Pilot studies are basically before collecting and going full-fledged out on our research collection, research analysis, we collect a small sample, we perform the basic test on it, and then we can also have feedback from the respondents, from the potential respondents, from the experts. We do the face validity. Okay, and that is what is we meant by triangulation, member checking, comparison with similar conducts. Then we also have factor analysis, we have confirmatory factor analysis, we have exploratory factor analysis. have expert review again for face validity, participants feedback, yeah, pilot testing. Pilot testing serves a lot of purposes here. I'll move on to the next, the initial slide. I'll reshare. So that was all about reliability and validity. Yeah, I hope the slide is visible. The older slides are visible. So when measurements are put into practice, so we test the hypothesis. Okay. So our hypothesis that are theoretically derived, supported by the observation. Agar nahi, so what is the problem with? Is there a problem with the applicability of the theory, or was there a problem internal validity with the research design, or there was a problem with the measurement? So we measured it through construct validity. So in seeking to examine construct validity, we must identify the antecedents and consequences. What leads to the concept, and what the concept leads to, or what are the effects of the concept. These are the 4 scales of data that we have already discussed. And then there we have parametric and non-parametric tests. So parametric test assume that there is a normal curve. So we're going to talk about this normal curve. This is usually for those of you who are from social sciences background, or who have had substantial acquaintance with the statistics and concepts. So this might be this is a bell-shaped curve that we talk about. So parametric tests assume that our data follows the normal curve of distribution, and it also assumes that there are continuous and equal intervals between the test scores, and with tests that have a true zero. So we use standardized scores, Z test ho gaya, T test ho gaya, F test ho gaya. Non-parametric tests are the ones which make few or no assumptions about the distribution of the population or characteristics. And again, there are pros and cons for both these. Like parametric statistics, it has characteristics or factors of the population are known, and non-parametric assumes that characteristics or factors in the population are unknown to us. And when we talk about the population parameters, we are talking basically about the population average and the population standard deviation. Another category, another type, or we can say the term that we should be acquainted with respect to research, is descriptive and inferential statistics. So descriptive statistics is basically used to summarize the feature of the sample or the simple responses. For example, frequencies or the correlations. And there is not much inference that we can draw from it. For example, when we talk about the mean or the average or the frequencies or the median mode. So all these are descriptive statistics. Inferential statistics is about, we have sample statistics, and from that sample statistics, we draw inference about the population parameter. So based on the results that we get from the sample, we try to generalize it for the population parameter. It's based on the probability. There's a margin of error. Yeah. So yeah, this is the explanation. On descriptive statistics, we have mode, we have the mean, we have the median. Obviously, mode is what the greatest number of the people, or the answer, the response, or the score with the highest frequency, for example. Mean would be the average score. Median would be the one which divides the entire distribution of data into 2 equal halves. Yeah? Then we have minimum and maximum score. Then the difference between the maximum and the minimum score. Then we also have the variance, which is nothing but the square of the standard deviation. I'm sure I have the standard deviation. Yeah, this is the formula for the standard deviation. We take deviation from a certain value. We square the deviation, we divide it by the total number of observation, we take a square root, we get the standard deviation. Standard deviation tells us how much variability is, or deviation is going to be there in our response from the measure of central tendency. For example, if I am saying that it usually takes me 45 minutes on an average to come from Dwarka to say HANSRAJ college. So that is the central measure of tendency here. Average, on an average, it takes us 45 minutes. Okay, but it might also be a bit early, or the actual observation. So if I record my data for my past months, route from HANSRAJ, from Dwarka to HANSRAJ college, so there might be delay at say certain metro stations like Rajiv Chowk when there's a huge traffic. during the office hours. So actual observation might actually fluctuate from say 40 to 50 minutes also, and sometimes it is taking longer. Yeah. So standard deviation is what tells us the range of deviation or the variation in the data. Yeah, so the standard deviation, standard error, skewness, and kurtosis, all these are descriptive statistics. Then we have inferential statistics also, wherein we draw inferences. For example, yeah, considering the same example, the time it takes me to reach to my college, the relationship between the time that it takes me to commute every day on the effective teaching. Yeah. So what will I have to do? I will have to run a correlation, a regression analysis. I will have to collect data from my students as to rate my teaching on different days for a particular time period. And I will also have to look at the time that my commute has taken during those specific days. And then I run a correlation between these two series of data. Okay. And then I can draw an inference on the days when it took me higher time to commute were the days when my teaching got negatively impacted. Yeah. So there are tools for that. Correlation is there, regression is there, then there's different variation of regression, again, depending upon the type of data. For example, for time series data, we have advanced regression methodologies like that. We have GARCH, which is generalized autoregressive heteroscedastic time series analysis. We have a difference in difference approach. We have structural vector autoregressive models. Similarly, we have factor analysis. We have confirmatory factor analysis. We have exploratory factor analysis. We have, again, this can be done on SPS AMOS, or we can also equation modeling. That again is a software and also a technique. That could be done. So all these are tools of inferential statistics. So inferential statistics, descriptive statistics just gives us the idea as to what my data looks like. Yeah, it gives me number to deal with, but I cannot draw inference out of that. Yeah. For inference, I need to use certain other kinds of methods like correlation and regression and certain other advanced methods. So yeah, so simple statistics are there: frequencies, mode, mean, and standard deviation. These are simple statistics. Obviously, we cannot perform standard deviation on a nominal data. That is what we discussed earlier. For us to calculate standard deviation, we either need to have interval or we either need to have ratio data. Similarly, for mean, we need to have internal ratio data. For example, I collect data on number of male students and female students in my class. Yeah, so I cannot calculate mean of the number of males. No, that will not fetch me any information. But if I am collecting data of say statistics marks in my my class amongst males and females, then I can calculate the average of average or mean marks of girl students versus boy students. That is doable because marks would be what? Marks would be ratio data. But male gender will be what? Nominal data. So I can have frequencies for the raw scores, frequencies for the gender, but not standard deviation or mean for that. Okay. We can have mode. Yeah. More number of girls scored higher as compared to the number of boys. So we can calculate the mode of boys score and mode of girls score. So that is doable. So depending upon the kind of data, we need to figure out what kind of descriptive statistics we can employ and what kind of inferential statistics we can employ. So yeah, again, when we talk about regression, so we have two sets of variables. One is dependent variable and there could be multiple independent variables. For example, I want to check impact of rainfall on the wheat or rice production in a particular area. So here, independent variable would be the quantum of the rainfall, and dependent variable would be the rice produced or the wheat produced. Yeah, so we have independent variable, we have dependent other terminology that we use. Endogenous is a dependent variable, exogenous variable is also independent variable. We have different terms for it. Then we also have moderator and mediator variables. Moderator variables which affects the strength of the relationship. For example, I want to say measure. So I am measuring the impact of financial knowledge on say behavioral biases. Okay, financial knowledge on behavioral biases. Now, gender might have a moderator role here, or say financial attitude might have a moderating role. Mediator is when the impact gets transmitted through a variable from A to B and then B to C. That is mediator variable. And moderator would be A to C, but B is impacting the relationship. That is moderator variables. B in that case becomes a moderator variable. Categorical, discrete variable, continuous variable we've already discussed. So these are the 6 initial questions that we should. What kind of scales are there? Is data going to be parametric or non-parametric? Are we going to use descriptive or inferential statistics? Is it required? What is the dependent and independent variable? What would be the independent variables we need to identify? No, ऐसा नहीं कर सकते हैं that we skip certain independent variables. Our model will not be robust. Our results will not be worth interpretations. We need to have we need to do due diligence in identifying what is going to be what are going to be the independent variables in our model. Yeah? And where does that come from? That comes from the literature, the different theories, the work of the past researchers. Okay. So another important question: are the relationship going to be linear, or are we also going to talk about non-linearity of the data of the relationships? So univariate, when we look just amongst the look for the differences amongst cases within one variable. Bivariate when we have 2 variables, and multivariable when we have more than 2 variables. For hypothesis, we have null hypothesis, we have alternate hypothesis. The null hypothesis is a stronger hypothesis requiring rigorous evidence not to support it. So we as researchers should always start with the former, that is the null hypothesis, and cast the research in the form of null hypothesis, and only turn to the latter in the case of finding that we do not have sufficient evidence to prove null hypothesis or support null hypothesis. Then direction, there are one-tailed test or one-tailed hypothesis. For example, people who study in silent surroundings achieve better than those who study in noisy surroundings. Two-tailed would be that there is difference between people who study in silence surrounding and those who study in noisy surrounding. And now this difference can be positive or negative. That is two-tailed or no direction. This is unidirectional, one direction, wherein we are assigning the greater than or the less than sign. There are certain other terms. Yeah, this is what a normal curve of distribution looks like. So we have at 0 we have the average value, and what this normal curve assumes is that 68.3% of the data will lie between mean plus minus 1 standard deviation. So this area from -1 standard deviation to 1 standard deviation will constitute 68.3% of the data. Similarly, mean plus minus 2 standard deviation will constitute 95.4% of the data. And similarly, plus minus 3 standard deviation, mean plus minus 3 standard deviation will constitute 99.7%. So this is a normal curve, normal distribution. That's the assumption that comes. So yeah, that would be all for today's session. And the whole objective was not to go into the depth of each of these topics, but to revisit the different concepts that we as researchers must be acquainted with. And yeah. Thank you, everyone. If you have any queries, you can please, I can wait for another 2 minutes, and then we can, if you have any queries, please post it in the Q&A section. I'll be more than happy to answer the queries.
Participants, you can.
Or if you want to have any addition, any comment, anything that you want, please type it in the Q&A box.
Anyone have any questions. So I would like to extend
I would just a moment, ma'am. Just a moment. Just a moment.
okay.
I just want you all to answer to a poll.
दिलवाएंगे तो नहीं।
I would like to hand over the session to our patron, Professor Malaviya. So please address the session.
Thank you, ma'am. May I audible?
Mute yourself. संजीव सर आपके पे माइक में कुछ इश्यू
Thank you, Ashutosh ji.
you are audible. आपके माइक में
Good afternoon to everyone.
anyway for the participants I have put in a
For this session, our resource person is Professor Vimal Rarji, Director, Malaviya Mission Center of UGC, Professor in Department of Chemistry, SGTB Khalsa College, Delhi. Ma'am is available.
Dr. Sinji, I think there are some issues at your end.
Ashutosh ji,
Has not
ma'am
yet
hai.
joined. Please wait.
आशुतोष जी मैम शायद कनेक्ट
The ma'am will be joining in a while. Please wait.
ओके ओके
Please wait. Please wait. Meanwhile, I would request the participants to answer the poll that I've just shared. Dr. Sinji, Professor Vimal will be joining in a while. Meanwhile, participants can take a break for 10 minutes. She will be joining by 3:30, 3:35. Okay, with that, I will take your leave. Thank you so much. It was a wonderful experience, wonderful session. Thank you, everyone.
Thank you, sir. So I would like to extend my heartfelt thanks to you, sir, for delivering such an insightful and engaging lecture on research and development. The wealth of knowledge you shared today, particularly your emphasis on innovative research methodologies, the importance of fostering research-driven environments, and the analysis of data by application of various statistical tools and techniques will undoubtedly inspire and guide many of us in our own academic and professional journeys. Thank you so much, sir, for a very informative session. We look forward to many more opportunities to learn from you in the future. Thank you so much, sir.
Thank you, ma'am. Thank you. Namaskar.
Welcome back, everyone. I had a refreshing day. Let's dive back into our session and pick up where we left off. Now, Principal Sir, Dr. Naren Kumar Batra, to welcome Honorable Professor Vimal Raj, Director, Guru Angad Dev, Malaviya Mission Teacher Training Program, and Professor, Department of Chemistry, Naren Kumar Batra. Principal sir,
Yes.
are you there?
Thank you, Shraddha ma'am. Am I audible? Am I audible, ma'am? Ma'am, may I audible?
I think there is some technical issue. Let me check. Yes, sir. Yes, sir.
Yeah, good afternoon, everyone. I think you'll have to make.
Yes. Let me do that, ma'am. Yes, you are host now, sir, ma'am. Principal sir, can you hear me?
Yeah, good afternoon, sir. Thank you.
Good afternoon to everyone. For this session, we have a special resource person, Center of UGC, Department of Chemistry, SGTV, Gandhi. It is a pleasure lectures, biology and assessment and evaluation. Enrich to evaluate and assessment and how to develop our curriculum and how to use such a course. So I am not clear between Professor Vimalji. I would like her lecture. Thank you, ma'am. Thank you. Ma'am, are you clear?